In September 2016 I was approached by a guy called Angus Campbell to ask if I would be able to machine some castings and part machine castings for his BSA Fury engine. Now Angus has got a couple of these things. He's got one working one, and this one I believe was a display bike, and he wanted the engine made up so that it would possibly turn over but certainly have all the internals in it, because the display ones went around the States without any internals in the engines or whatever, way back in the 70s when they were first bought out, or the 80s. The engine itself intrigued me. It's a nice design in some ways. It's a double overhead cam, unusual, and certainly for the time a very nice engine, very much like, reminded me of a Honda sort of thing, but still a nice engine, very compact, quite heavy. I was surprised, but gave fantastic performance. I think where BSA went wrong, they pitched it at the 350 market thinking America would be buying them, and of course America likes lots of CCs, and at that time so did we, and still do. Smaller bikes don't command the market that bikes of a higher capacity do, and that's the way of the world, and BSA went to the wall. The story is that these castings came from Umberslade Hall, from the scrap bins or whatever, when the place was being bought out, and Angus had managed to acquire quite a few pieces. So a few weeks after that he brought the pieces to me, and I was then able to have a look at them and give him my verdict on whether I could do them or not. And what I saw, I thought, well, I can give it a shot for what he wants, and therein I started work on them. All I had to go on were part machine castings, which can be a help, but they can be a hindrance as well. And I had the spares booklet and the spares drawing, indicating all the spares numbers, but it was a nice drawing. It was a really large scale drawing, and I was able to get a lot of information from it. I certainly couldn't get sizes from it, but because things were partially machined anyway, I think that in that respect it helped that I didn't have to sort of work any sizes out, and I was able to proceed with the job. So over the next few episodes I will cover the machining of these castings onto the point where the engine left my hands, which is basically I got the whole of the bottom end built up. The gearbox had me defeated, but there was not a great deal wrong with it. And also the cylinder head, I wasn't prepared to do the cylinder head. It's not something that I've done very much of, and I don't like fitting seats into heads. I think it's best left to a specialist, and that's when it left my hands. And since then I believe Angus has fitted the engine into the frame, and he is waiting for the head coming back from a head specialist who's putting inserts, valves, guides, everything in the head, and hopefully it will run. There were some big challenges, and overall I think it went quite well in the end. But as I say, we'll cover this in I don't know how many episodes, but I've got plenty of film of it. Hi, welcome to the workshop. The job in hand today is a long-term project. It's the machining of a set, or a crankcase, half casting plus a part machined half casting, which are going to form the basis of a BSA Fury engine. The engine is a 350 overhead cam, design from the 1970s, designed as a last-ditch effort to try and beat off Japanese competition. Unfortunately, BSA ran out of money before it could be completed, and the castings were rescued by some enthusiasts, and I've been asked to machine them, They look to be pretty straightforward. I hope they are. There's also sent me some drawings which I can follow, but they aren't dimensioned, but they're pretty well drawn, so they give me a lot of ideas as to what goes where and how things need to be in terms of alignments, etc. Also they supply me with a crankshaft and a couple of bearings, which they're brilliant because it means I can fit the crankshaft into the engine with the conrods on it, by the way, and I can also line everything up once I've machined one bore in particular. So it's looking pretty good for, I hope, an easy job. The first thing I'm going to do is just take a light skim across the top so that I can turn it over and then take another skim off the other side, off the outside of it, and give me a nice parallel datum faces to work from. So that's what's going to happen next. Okay, well here you see some partially machined castings. This one is almost machined fully. Still got some machining to do on the cylinder base and the studs. This is as it came from the BSA factory in 1972, and this is a raw casting. The colour is like that because somebody has taken a mould from it in case there's any problems during machining or for further copies. Now the first task I have to do is to clamp this to the base of the machine and clean off this face and make a 7-inch diameter spigot on here. This bearing hole here fortunately is straight through, so it's a parallel hole. The intention will be to make some dummy bearings to fit on the crankshaft so that I can leave this in situ on the machine and lower the crankshaft into it at the same time, checking the distances and the spacings from this crankcase half, the crankshaft and the lower half. So that'll be the first task, will be just take a skim off here and machine a spigot and machine it down to the correct, more or less the correct distance between this face here and here. Okay, so we're going to be machining this using PathPilot conversational programming. I've already set it up and hopefully it will work okay. I don't think I'll bother, well I might bother with coolant on the last cut because I don't want the compressor kicking in halfway through. It's quite noisy, although it doesn't really matter that much. However, we'll make a start. I'll go on single block at first, just to make sure everything looks okay, and once I'm happy with it then we'll set it running. That's looking pretty good there, so let's just come off single block now. Let's see how it looks. It might cut air for the first time. I didn't want it too close to the casting. I don't know how even it is. It's quite a large area to get ready, but anyway, we'll kick on some coolant. Very noisy, and you can see it's not actually got in there yet. And of course the compressor kicks in just when you don't want it to, but never mind. Just move this up a bit so we get a better view. It's handheld at the moment, so it's not so good. However, there we go. Quite slow feed. I'm not in a hurry. And there you see. So we'll come back to it when it's actually taken a cut. We'll just still on the first cut, but if you look closely here at this part, you're very careful with this fly cutter. Keep your fingers well out of the way of it. You shouldn't really have them in here, but this is just for the purposes of taking a film. And you can see there, it's just touched that little piece there, which is what I thought was a highest point, because I can see a bright spot from where people have been sitting it down. So the next cut will take a little more, but it's producing a nice finish without coolant, so I'll probably leave it without coolant for just this pass anyway, or for the purposes of this skim, if you like. Anyway, we'll see how it progresses. I think all the surface is covered by this, so it's looking pretty good. Yeah, I'm pretty sure I don't think any parts will be missed by the cutter. I think I've got it all correct. So we'll see what happens on the next cut. The more that it exposes, the better. Like you see there, we're just done the second pass, or almost finished the second pass. It's machined a little bit off here. And a bit more off there, and still a good finish. A little bit, I think it's because it's casting. I'm used to machining HE30 alloy stock, and it certainly machines with a nicer finish than this, but it's still a pretty good finish. So I'm carrying on without coolant. It's just about finished that second pass, so we'll watch what happens on the third. I'm hoping by the third pass, which will be just under, well, just over 1 millimetre cut off, that it's taken some of that the furthest corner away, which is just behind the spindle now. So hopefully it'll just touch there, because it must have been touching in 3 points when it was turned over. I can see bright spots where I've chose the highest point and it turned out to be that. So hopefully here goes. Again, I'm not using high speeds. I don't need to at the moment. It is nice to make things work, but the fly cutter, it's not very well balanced. There we go, that's good. That's exactly what I thought. There we are. And that's nice. So that's it in 3 places. With a bit of luck we'll get some on this face here. I'll keep my fingers out the way of that. I tend to be a little careless at things. It's so easy just to put your fingers in where they shouldn't, like right there. That was a compression ignition engine I built, and I'm trying to start it, and I was trying to adjust carburetors and choke it and do all sorts all at the same time, and I shouldn't have been, and that's what you get for being careless. And there we go, that's nice, that is nice. It's just covers most of the, I hope it does anyway. We'll soon find out, because let's see. If it doesn't cover all around, I may have to adjust the step over, so it'll take a little bit longer, but never mind. I'll get all of it machined somehow. All of this face, here we go again. So it's fine, it's looking quite nice for flatness. Now here we are on the 4th pass, I believe, yes, the 4th pass. And it's cutting a lot more. It cuts all the areas, so everything's covered. I've got the fog buster on, coolant. Normally I would have the guard in front of here, but for the purposes of filming it's left off. It just means I have a lot of cleaning to do around the workshop when we've done any heavy work that I'm taking films of. But I think another pass or so and it'll be fine. I should be able to stand it, and it's that was quite warm, that buddy. Should be able to stand it flat I'll set it flat on that surface that's been machined now, and take a bit more off the other side, but I want to get it looking as though it's been machined, so we'll see how it goes. Here we are back, well I haven't left, but here we are at the table of the mill. As you can see, I've machined the underside now. I've got a flat surface to work from, so I've turned it over, bolted it down. I've centered it on the inside of the casting here, and it's pretty accurate. It's nice and round. I used a centering tool for it. It's nice and central in the bore here as well. Obviously the pattern making was pretty good. So the next phase will be to bore this out, just through bore it to close to bearing size, and the idea then is I'll take it out of here and put it in the oven and get some idea of how much it expands at 150-200 degrees, and work out what bore I actually need to make the hole from that. So that'll be the next job after this. So we'll get this job started and see. You can see here using conversational programming. This is Pocket conversational wizard, and I've got it set up, so we'll see what happens when I go into cycle start. I'll take my max file right down, click in the cycle start. I don't want coolant, that's off, and here we go. Slowly bring it down. Just want to make sure that the tool clears the top of the work before it goes down. And it's looking good, can't do any harm there now. Coming up the centre. Looking good, looking good. 105mm, 70, something out here, 30, 25, yeah, that's looking good. That's it. And it'll take a while to do, but there we are, there we have it. We'll see what happens as it hits the metal. Always keep looking for the police cars when I hear this sound. It's going to take a while, this one. Very slow program, but I'm not bothered. I'm taking my time with it. There we go. Just want good result. Well, that's the cutter making the first contact with the work, and it's pretty good all around. It's very, very accurate to the outer part of the casting that I centered everything off. I think there's very little in it. That's lovely. It's really doing what I want it to do, which is great. That's the first pass done. I've taken this out a little bit more just to be fairly close to the finished size. There's quite a bit of metal that you can just see at the lower part of the hole. It's not being machined, so it's a lot easier to measure when there's a full hole that's been machined, so I might as well take it out fairly close. I can pick up this bore very accurately within a thousandth of an inch using the equipment I've got quite comfortably. It's not a big problem, so I'll get this a little bit more out of here, and then it leaves the groundwork ready for the real complicated stuff, or not the complicated stuff, but the accurate stuff. Yeah, the idea behind the false bearings is basically, on the dummy bearings, is so that I can put one crankcase one part of the crankcase in one crankshaft in the crankcase. This is already in one of the dummy bearings, and when I machine this to the correct diameter, this dummy bearing will be a slide fit in it, and I should be able to just drop the crankcase over the top with that bearing in place and just check all my physically whether, you know, how much clearance there is for, you know, how good on centre the rods are in both bores, etc. Once I'm happy with that, that's it. You know, as long as they're the correct thickness. This isn't critical because there's plenty of room in this housing for it to go in any position. As long as the conrods are central in the bores, then I'll be happy with it, and we'll be able to close up the crankcases quite nicely. Put a spigot on the other half so it joins in here, and it should really look good. It's a nice little engine, this. I like the look of it. Anyway, that's the reason for the dummy bearings. Well, I've just taken another measurement, and it's very hot. It's over 100 degrees Celsius, and there we see it's actually 2.729. So that's how much it's expanding. I'll have to look back and see what the initial measurement was, but we'll find out the total expansion. Okay, I just looked back through, and the previous measurement was 2723, and this is 2729, so that's 6 thou expansion. That's what I expected kind of for this. Having just taken a skim off both surfaces to provide me with a reference and check measurements, I'm now in a position to machine the spigot that's on this part of the casting. It fits into a recess in the other half, which is already machined. It's only about a 1/16 thick by probably a 1/16 deep, but I need to machine this part, check that it fits in the spigot, make sure it fits, and then I have to bore out this centre so that I can take a bearing or use a false bearing which I've made, just to check that the position of the bearing is correct in this housing here. I'll probably leave about 5 thou clearance between the end of the bearing and the crank for expansion. That should be about as much as it will expand that way. It has to move, it has to expand in this direction, because at this end you have a camshaft drive which is a fixed position, so everything moves away from that point. So I'll try and well, I'm going to give the program a quick try. This should leave it 5 thou oversize. I've got another program which I'll run if I'm happy with that being 5 thou oversize when I check it. That goes to exact size. I'll run the exact size straight after that one, and then I'll be in a position. I might have a little bit of hand filing to do here, or a little bit of machining on this part, because this fits into another part on the crankcase. So we'll see how it goes. Well, just running that program without a cutter in. As you can see, there's a lot of air to cut. It was a very simple program. I just told it this was a 12" by 8.5" piece of metal. It's just been cutting this corner of it, it's cutting this corner now, it's going to each corner in turn. It looks as though it's going to be okay, so I'll probably stop it once I'm happy that it's going to reach all 4 corners, and then put the tool in. And here we are with the oversized cut, the first trial of just making the spigot. It seems to be going okay. On reflection I should have maybe snuck that tool a bit further up into the hole. That's got quite a large overhang and it's a bit noisy, but it's okay, it's putting alright. A little bit of chatter there, but not too much. Coping well with it. And there you can see it's not too bad. Here we are, just about to start the final cut to get us to the correct diameter. It's going to take 2.5 thou off here and 15 thou off the dent, I hope. There you can see the crankcase half, the one that's already been part machined. and it's a good fit on the spigot. In fact, I can't even turn it. It's not in line because there's a little bit of flash on here that needs just dressing off with a file, so that I can rotate that around, and it comes into alignment along here. It's looking really good. I'm very pleased with that. It looks great, and the crankcase halves are now all it has to be, ready to be bored out to take the bearing, this main bearing down here, and that'll be the next phase. Using the same 0 setting that I've got here, I will bore it out using the boring head and make it a few thou undersized so that I can expand, heat the cases and get the bearing in using a bit of heat. So that'll be the next job. Okay, currently I'm just boring out the bearing housing. Okay, well, currently I've done all my measurements and I've got the boring head in the mill. I've got a little program there that will bore down to the bottom. I'm not sure how far down it goes. It's very close to the table, so as soon as I hear it's finished cutting through the housing, I'll stop the program, wind it back up in the Z-axis, put a little cut on and restart the program. It's a very simple, easy way of doing it. I've already put a cut on this, so let's give it a try again. I'll just switch on the coolant, and here we go. And should start cutting about now. The light's not very good. Put switch on the light in the workshop so you can see. Now there's the compressor running. As soon as I pick this camera up, the compressor starts. Anyway, you get the idea. We're boring out that for the housing. I've already done my cold and hot measurements, so I know what to bore it. This is the final cut on the bearing housing. It brings up to 2.830, or it should do, within half a thou or so, and that gives me nicely within the range of the expansion of the casing combined with the expansion of the bearing at the same sort of temperatures. It'll still hold. One of the problems a lot of people have is they machine too large, and then as the cases heat up, the differential expansion between the two metals are different and the bearing starts rotating in the housing. This shouldn't happen with this. Even at the highest temperatures, it will still have about 1/1000th of an inch shrink on the bearing at full work, at more than full working temperature. At seized temperatures even, it should be okay. I'm pretty sure of that. One of the essential things here was to machine this and this at the same setting on the same 0 for the centres of that hole, so that you get concentricity with the cases. It's spot on. Now the next thing will be to remove this clamp and put it back down, put it here. So I've got a decent bit of clamping. Oh, the fly's just landed on the job. Got decent clamping, and I will take this little bit of flash off here, put the other case on, and then spot through for the various holes, so that we can join the crankcases together and see what else we can machine after that, because the next phase will be to machine these faces after I've drilled and tapped these holes. So we'll see what. Okay, now you can see the crankcases put together. It's a casting. I had to file a little piece of this flash off here. You can see it's a good tight fit. It just rotates on there. It's now a case of just finding the sweet spot, if you like, so that everything's as close to being in alignment as it can, casting wise, and that is the actual position. If I go on these two pegs here, just about right, that hole there's just nicely in the corner. There's an even line of material there, and it's just slightly out here. So I think we'll probably spot through from this position the holding down bolts for the bolts that are needed to hold the crankcase halves together. I can only do 1, 2, 3 initially from this side, and then once I've got it joined together, I can then turn it over and do the other 3 from the back side and drill and tap the other part of the case. Well, I believe this part has already drilled and tapped, but I will find out sooner or later. But that's a beautiful bit of progress on the engine. Really not much more to do before I can try the crankshaft in there, just with the dummy bearing, and see how well it rotates, etc. And then I can start thinking about machining this and spacing out the cylinders so they sit in there. And when I've got that done, that's a good part of the engine finished, really. But it's looking really good. I'm pleased with the progress.